This meeting is being recorded.
Yeah, cool.
Hello, everyone.
Good evening, everyone. Yeah, you can start now.
Hello, everyone. Welcome to this third episode of Building an AMM. Um, we've gone over just to do a bit of recap. We've gone over what AMM is, what it stands for, how it operates in the market, what sort of operations and possible models in AMM could take in the Web 3.0 space. Today we're talking about 8 AMM formulas. I will really be focusing on the AMM constant product model, right? So for those who can still refresh themselves, so the constant product AMM has a different formula over the rest of the different models. So I'm going to start going into the constant product AMM formula, and then we'll see how that goes through into the mathematical equation. So what is constant product AMM, right? So this is a model where the price of tokens are determined by the equation x multiplied by y is equals to k. X is the amount of the token A in the AMM, while y is the amount of token B in the AMM. Now, x and y can vary, but k must remain constant, right, in the equation, because k is about the total liquidity. So we have a simple example. We want to say we sell token A and buy token B, right? So what is the change of amount of token of the token in A, right? So we're putting in token A and we're taking token B out, right? So dx will mean amount of token A in the contract and dy amount of token B out of it, right? So before the trade, remember that we say for a constant product AMM, we have the equation x multiplied by y is equal to k. So after the trade, we have x plus dx multiplied by y minus dy. For just to explain this, dx A is the amount of token x that came into the trade, dy is the amount of token B. Sorry, amount of token A that came into the trade, and dy is the amount of token B that went out of the trade, and is equal to k, right? So k is constant in this equation. So if we're thinking about swapping tokens in an AMM, right, we're actually swapping for dy, right? dy is a change in token B, right? So dy is equals to, we're trying to find what dy is, which is equal back to y dx divided by x plus dx, right? So I'll explain how we got into this equation. So we swap from token A to token B, right? dx is the amount of token A in, and dy is amount of token B out. So again, back to before the swap, the situation before the swap, x multiplied by y is equal to k, which is the equation before the swap. Now, after the swap, we have x plus dx multiplied by y minus dy is equal to k, right? Now, dy is equals to, right, dy divided by y minus dy, right? If you take dy if you multiply this equation by minus 1, you now have dy over y minus dy equals to k, right, divided by x plus dx. So k comes here, right, and dy comes over here, right? So this will now leave us with dy equals y minus k, right, divided by x plus dx. So this is what dy is, right, and it's back to the situation we had initially, which is closed. So remember that k equals to x multiplied by y from the first equation. So if we substitute k in the equation, right, we'll have, if you substitute k with x multiplied by y, which is what you actually have, right, in this start equation before trade, that x multiplied by y is equals to k, right? So if you substitute that, you now have equals to y minus x multiplied by y divided by x plus dx, right? So k has taken the position of k, xy has taken the position of k, right, in this equation here, right? So meaning because we have the situation x multiplied by y is equals to k. So moving on. So if we simplify this equation going forward, right, we have by multiplying y with the denominator x plus dx, we have yx plus y dx minus xy divided by x plus dx, right? So yx and x minus dx, yx and x multiplied by y can be cancelled out, and then you're left by dy, right? Dy equals to y dx, because we're looking for dy. So y dx divided by x plus dx, right? So this is the equation of what dy is, and it goes back to this same equation we had in the beginning, right? So both equations are similar. So if you say, so if you say this is the equation, then the reverse of this equation for token B, right, to token A is the same, right? So it's basically dx equals to x dy divided by y plus dy, which is basically similar. You just reverse where y is and where x is. Besides, please, if there's any question as I'm going through, please just raise your hands in the chat, and then we'll take the question. So adding liquidity, how many shares are we to meet in the constant product AMM? So if we take the equation, right, for how many shares to meet, we get S, which is equals to the shares to meet, and T represents total shares. So the equation is S equals to dx all over x multiplied by T equals to dy all over y multiplied by T. And remember, we said x is token A, y is token B, right? So how many token A and token Y to add in an AMM to add the liquidity? So before we add the liquidity, we have the equation x multiplied by y is equals to k, right? That is before we add. So after adding the liquidity of the tokens, we have x, the equation x plus dx multiplied by y plus dy equals to k prime. K prime is the new quantity of tokens in the contract, because the initial formula was x multiplied by y is equals to k. So this is before you added liquidity, right? So you are increasing k, which is why you now have k prime as a new liquidity, right? And so there are some constraints on what the addition of liquidity will bring to contract, to the AMM, sorry. So in terms of constraints, there are no price change before and after adding the liquidity, right? But we must always understand that the amount of token price are determined by the amount of the x of y ratio in the tokens of the AMM. For instance, token A, the ratio of token A to the ratio of token B in the AMM. So this means that x divided by y is equals to x plus dx, right? Divided by y plus dy, to signify an increase in the supply of the tokens in the contract, which is k, right? So let's think about this a little bit. What is dy given dx, right? How much of the amount of token A we want to add given the constraints of token, right? And also, what is the reverse case of how much of token y we want to add given constraint of token b. So let's start with the first scenario. What is dy given dx? So we need to find what dy is. And that is x divided by y equals to y plus dx divided by y plus dy. So if you cross multiply this equation here, right, you get x multiplied by y plus dy, right, is equals to y multiplied by x plus dx, right? And then you expand this equation further, right? So you get xy plus x dy equals to yx plus y dx, which is similar to what we got initially when we're trying to get one token. So if you divide this, right, if you xy is equal to yx, right, you're left with dy is equal to y, the change of x, all over x, right? And then this is also the same reverse case for, so we've answered this, the first question and second question. So this is also the same reverse case for dx, which is x of the change of y divided by y equals to the change of dx, right? Both equations will lead us to the scenario where we have dx over dy, which is change of x over change of y is equals to x divided by y, meaning that this ratio of amount of tokens to add must be equal to the ratio of tokens before adding liquidity. That means this is our initial scenario, right, where we have dx all over y, which is the two tokens, token A and token B, right? The ratio of token A must equal to the ratio of token B in the AMM, right? So we are constrained to answer the questions of what constraints do we have on adding liquidity. We are constrained to the formula of dx all over dy equals to x all over y. So this is the constraint that we'll have in an AMM. And anytime we want to add token, it must be a ratio of token A to the ratio of token B that must be added into the AMM, right, for constant products AMM, right? So thinking about every time where tokens are added into AMM, remember I said liquidity providers, if you go back to our first class on AMM, liquidity providers always receive a share of the proportion of amount of tokens that was added to the AMM. So if, for instance, liquidity increases, if K, right, K is the liquidity. If liquidity increases by 5%, right, then the total shares must increase by 5% in the AMM. That means the shares that will be given to the liquidity provider will increase by 5%. And so what is the equation when that comes to mind? So we have L1 divided by L0 equals to T plus S divided by T. So where L0 is the liquidity before, L1 is the total liquidity after the transaction, right? T is total shares before, and S is shares to mint, right? So how does this change? So we say L1, which is the new change in the amount of tokens added, right? Sorry, amount of shares added, right, over the old shares that was available equals to T, right, plus S divided by T. So we need to solve for S to find how many shares to mint. So if we multiply this both sides by T, right, we get L1 divided by L0 multiplied by T equals to T plus S. Now we take T from the right to the left, and we get L1 divided by L0 multiplied by T minus T equals to S. And then if you simplify this equation a little bit further, you get L1 minus L0 all over L0 multiplied by T equals to S, which is the initial formula here, right? So this is where I'm going to try and stop today. If you have any questions, let me see if anyone raised their hand. Anyway, I'll get to that. So assignment for this class. This is we've talked about addition of tokens to the contract. We're talking about swapping of tokens to the AMM contract. So I was talking about shares to mint. However, going forward, I want this class to be a little bit proactive. So I said, let me put in a couple of assignments. So how do we measure equation? How do we measure, what is the equation to measure liquidity in an AMM, right? And how do we simplify the equation for shares to mint? And what is the equation to remove liquidity tokens from an AMM? Please do research on these 3 questions and put your answers in the Discord channel. I'll be taking, I'll be looking over the next few days before our next class to see how many people attempt to answer these questions. That will be all for today. Thank you for joining this short class. See you till the next class. Thank you.
Thanks, Benedict. Thanks, everyone. Thanks for joining.
Any questions?